As most of you know, SAM is a free computer program that you can download from NREL's website. And basically what the model does is it calculates a renewable energy system's hourly energy output over a single year. So it simulates the performance of a power system over a year, and then calculates the cost of energy of that project over the life of the project. So conceptually, the model combines a performance model with a financial model. Here's a diagram of the structure of the program. There are basically three conceptual parts to the software. There are the input pages, which we'll see in a moment, and then there are the model results, and then there's a simulation engine that makes calculations based on the input variables and reports the results. There are some more advanced features, including Excel data exchange and SAMUL scripting, and some advanced simulation control options that we'll be covering in tomorrow's session. This next slide sort of shows a little bit more sort of the conceptual model to help you picture what's going on with SAM. So the simulation engine is an hourly model, as I mentioned before. It's based on Transys, which is a simulation software developed at the University of Wisconsin. The simulation engine does an hour-by-hour simulation of the power system. So it, in order to do that, the hour-by-hour calculations, it requires hourly weather data, which you provide as input to the model. So you've got a weather file with 8,760 hourly data points for the solar radiation, temperature, wind speed, and other weather factors that affect system performance. And then you also have the system description, which is tells the simulation engine what size of system you're modeling and what components your system is made of. So the two green blocks are inputs, and the red circle represents a calculation process. And then the blue rectangles represent outputs. So the simulation engine generates a set of hourly outputs, a set of hourly values representing the electric output of the system. So kilowatt hours for each hour of the year. And that's the basic output of the simulation engine. It also outputs some intermediate variables. So if you're interested in looking in more detail at how the system is operating, you can see, for example, the energy output at different points of the system, perhaps coming out of the solar array for a PV system, or coming out of the solar field for a concentrating solar power system. But the primary output of the simulation engine is the electric kilowatt hours for each hour of the year. Then SAM adds up those hourly values to calculate the total annual output of the system. So that's one number that is then passed to the financial model. And the financial model calculates the cost of energy of producing electricity with your system, and that runs over some long period, number of years. So it uses the annual output of the performance model for year one, and then calculates the cost of operating the system for each year over a 20 or 30 year analysis period. Okay, so next I'd like to jump right into SAM. This is what what you see when you first open SAM, the welcome page, and it provides you with 3 different options for getting started using the model. You can either start with a sample file. So here's a list of the sample files. So sample files are files that we've prepared that have a complete set of inputs and results for a range of different systems and different technologies that SAM can model. You can also start with a new file or new project, and to do that you just type the name of your project under Create a New Project and then click Create. And then there's a list of recent files. So these are files that I've worked with over the last few weeks. These 3 options are also available under the File menu. So File, you can start with a new project, open a sample file, or look through a list of recent files. These other options, this open a SCIF file, is for anyone who's used version 3 of SAM, which is a legacy version. That uses a different file format. So if you have files that you created using SAM version 3, you can save them as a SCIF file and then open them in the current version of SAM. Okay, so I'll just start with by opening a sample file, and I'll start with the sample P system to show you around the user interface. A SAM file or a SAM project, I'll use those 2 terms interchangeably, consists of 1 or more cases. And a case in SAM is sort of analogous to a worksheet in Excel. So an Excel workbook can have 1 worksheet or it can have several worksheets. In Excel, each worksheet is accessible by a tab, which are along the bottom of the page in Excel. But in SAM, they're along the top. Each case in SAM is a complete set of inputs and results. So they're intended to allow you to do comparisons of different analyses within a single file. So by switching between cases in the file, you can compare different analyses. So you might set up different cases to compare different financial scenarios, or you might set up different cases to compare different technologies, for example. So in this PV sample file, we have a case for a residential PV system, another for a commercial system, and another for a utility system. And as I click the tabs, I can see the results for the different cases. Along the left side of the window here, we have the navigation menu. And each of the items in this menu is actually a button that you can click. And by clicking each button, you display the input page. So for example, the climate page shows the input page where you specify the climate file for your analysis. Financing, there's the finance inputs. Payment incentives, those are the incentives inputs. At the bottom of under the navigation menu here are buttons that allow you to control simulations, run simulations, and also to display the results page. So this graph button with a bar graph on it here displays the results page, and this is where you see graphs and tables of the results after you've run simulations. One thing you'll notice about SAM, whether you start a sample file or a new file, is that the values on all the input pages are already populated. The variables are all populated with values. SAM has a large number of input variables, and so in order to help you get started, we've chosen representative values for all of the input variables. It's up to you as the modeler, once you start actually using SAM, to take ownership of the input variables and make sure that they all make sense for your analysis. These are values that we on the development team have chosen that are fairly representative of projects generally in the U.S. But of course, the values that you choose for your analysis are going to be very project specific and depend on the location of the project and also what type of project. So be aware that these input variables, these input values are representative. They aren't officially sanctioned values by either NREL or DOE. So the process for using SAM is to go through each of these input pages and either choose values for your project or change them. So some variables you choose values from a drop-down list, and other variables are fields that allow you to type values. And once you've specified values for all of the input variables, then you run the simulation by clicking the green arrow button down here, which is the Run button. The status bar up here in the sort of top middle of the page tells you the status of simulations when they run, and then once simulations are finished running, SAM displays the results page where you can explore the results. For more advanced analyses, you can use the Configure Simulations button here to access the advanced simulation options. And these, again, are ones that we'll be discussing tomorrow. So the basic process is specify your inputs, run simulations, and review results. And if you want, optionally, you can configure more advanced analyses. So the results page, again, to display the results page, I'm clicking this button with a graphs on it. The results page is divided into a couple of sections. Under the navigation menu is the metrics table, which displays kind of general metrics of your project, and I'll be going through these in a little bit more detail later on in the session. But just wanted to point out the metrics table here. And two of the more important metrics, which are annual energy. This is the total electric generation for this system over 1 year. So it's the electric output of the system, in this case in year 1 of the analysis period. And then the levelized cost of energy, which is one of the primary outputs of SAM. So in this case, we've modeled a system with a levelized cost of energy, or LCOE, of about 15.5 cents per kilowatt hour. Over on the right-hand part of the screen are where you see a bunch of graphs. SAM displays a set of default graphs, which we see here. You can also create your own custom graphs. And in this case, by default, we see 4 graphs, but you can change the number of graphs that are up here in the results page by clicking the little thumbnail images of graphs at the bottom of the window. So as I click buttons, I see different graphs. If I want to display 2 graphs, I hold down the Control key and then can display 2 graphs, 3 graphs, or 4 graphs. So you can display up to 4 graphs on the results page. The buttons along the top center of the window here control what you see in the results on the results page. So right now we're in the View Graphs and Charts mode. I can also view the base case cash flow table by clicking base case cash flow. So this is these are the results of the financial model, and each column represents a year. So year 0, year 1, year 2, and so on. In this case, we have a 30-year project, so there's 30 years of data in the cash flow table. And then each row in the table shows detail in the cash flow. The after-tax cash flow row is the key output of the financial model, and it's down toward the bottom of the cash flow table. This cash flow table is not an Excel spreadsheet. It sort of looks like one, and you can click the Send to Excel button here to export the cash flow table to Excel. But when you do that, this Excel spreadsheet doesn't have any calculations. Sam just dumped the cash flow values into Excel so that you can see them and manipulate them if you want to use them in your own external model in Excel or do some of your own graphing outside of SAM. So be aware that the cash flow table is not it's just a table of values. It's not connected to Excel formulas. You can also copy the data from this cash flow to the clipboard and paste it into Excel or any other program, or you can save the table as a comma-separated text file. For those of you running SAM on a Mac, the Mac version of SAM can't control Excel, so the Send to Excel option is disabled for Mac versions, but you can always use the Save as CSV option to save your data for use in Excel on a Mac. The Tabular Data Browser is a table building tool that allows you to sort of build tables of all of the outputs in SAM, or many of the outputs in SAM. So for example, the metrics list here is a list of all of the metrics that are available in SAM, and by checking boxes here, I can build a table of metrics. When you clear the checkbox, SAM removes the value from the table. And once you build a table, then you can send it to Excel or save it as CSV to export to use in reports or other programs. You can also export monthly data. So the monthly data, these are averages of the hourly data by month. And then you can also look at annual averages. So this is for each of the 30 years in the analysis period. These are the monthly averages, so months 1 through 12. I'm simultaneously showing monthly data and annual data on the table, which is why I have one column of 30 values and another column of 12 values. I'll clear all of those and show the hourly data. So if you want to dig into the details of the simulation results, you can display the hourly data. And let's look at the derated DC output. So this is the net output of the PV system for each of the 8760 hours in a year. So that's the main output of the simulation engine, but I can also look at intermediate values, like here's the total incident radiation. This is the energy incident on the PV array. And then I can look at the derated DC output. So this is the output of the DC output of the array. Sorry, I misspoke earlier. The main output is the derated AC output. So here we can see the progression from energy incident on the array, energy output of the array, and then energy output of the inverter or the entire system. So you can build this table and then you can export it to Excel to examine in more detail. There's also an option for looking at results that you can access either using the export and view data button here, or through the results menu. This export button shows these options are all equivalent to the options that are available on the results menu. So you can use either method to access these results. So here we can, the graph data option just exports all the data from the graphs to the clipboard or to Excel. That's sort of equivalent to this copy graph data button on the results page when you're in view graphs and charts mode. You can also export the cash flow table via the results menu. That's equivalent to choosing one of these buttons when you're viewing the page in cash flow mode. And then there's this case summary. So this is an Excel workbook that has a bunch of worksheets in it with all of the data. So here's the cash flow table in Excel. Here's the metric summary table in Excel. The data from the graphs that we were viewing in SAM when we created this summary spreadsheet. A summary of inputs, hourly data, the monthly averages, and annual averages. So the summary spreadsheet, some people find to be a useful way to look at the results. Again, you get to that from results, case summary, or by clicking the results button here and choosing case summary and then clicking send to Excel. Another option for viewing results is to use dView. This is by clicking either the View Hourly Time Series button in the Export Data window, or on the results menu choosing View Hourly Time Series. And this opens a separate program called dView that displays graphs of the hourly data. And it's a pretty nifty tool. It's kind of hard to interpret tables of, large numbers of values, like an 8760, a table of 8760 values. So these graphs kind of give you a snapshot of the data. One of the more powerful graphs in dView is called a DMAP. So once you open dView, you have options for viewing the 8760 data in various formats. One is as the line graph, so that this is looking at the hourly data itself, and I can look at the derated AC power, the derated DC power. I can show a second graph by using the two columns of checkboxes here. So I can look at cell temperature and inverter efficiency on the top graph. I can zoom in and zoom out, I can look at the entire year. The daily tab shows daily averages of the data, and again, I can use the checkboxes to choose what data I display. There's monthly averages, daily profiles by month, the DMAP, which shows a snapshot of the entire year. If you look at the AC power out, we have months on the x-axis and hours on the y-axis, so you can sort of see the daily shape for the entire year and also the seasonal variation over the year. And then there's other statistical summaries of the data. And you can export this data either as an image if you want to copy pictures of the graphs to include in your reports or presentations. You can also export the data itself. So if you click Export Data here, it'll just export the data that's visible in the graph to a text file, which you can then manipulate. So that's DView. And again, DView is a separate little program that SAM calls to display the hourly data. SAM automatically includes a copy of DView when you install it, so you don't need to install any separate software. But DView is handy if you have other hourly data on your computer that you want to look at. You can use the File Open command here to look at other hourly data. So that's a quick summary of viewing results in SAM. A couple of other things I want to point out about the user interface before I show you an example is one is this notes feature. You'll see at the top right corner of the page a little sticky icon that looks like a sticky note. If you click that icon and type some text, SAM will store this bit of text with the climate page. So it shows a little sticky note icon on the climate button to indicate that there's a note for the climate page. And then when you click on the climate page, then the note appears. So this is useful if you're sharing files with colleagues. You can make notes to each other, or you can make notes to yourself to remember changes that you made or to store values temporarily, and so on. You can have notes so these are tax credit incentive notes. That only appear when the tax credit incentives page is showing. You can store notes with the results page. Another feature is the help system, which is a useful resource when you're learning to use the model. There are a few ways to access help. One is on the help menu. If you click one of these options, you can display the help system. This is a browser-based help system. There's also a PDF version of the help system. So this is the same information that's in help, but as a PDF file. If you prefer to use that, you can print pages from the PDF file. You can also use the search feature in your PDF reader to find information. When you're on a page in SAM, you can press the F1 key to open the help topic for that page. So we're on the payment incentives page, and I pressed F1, and that opened the payment incentives help topic. I could also click the help button here, this little round circle with a question mark in it, to open the help topic for the payment incentives page. The way the help pages are set up, they open just showing the headings to kind of help you find information. So if you're looking for information about input variables on the payment incentives page, then you can expand the input variable reference heading to see a list of all the input variables and descriptions. And you can expand and collapse the headings using the plus minus button at the top of each topic. And then these buttons over on the top right, you can open your email browser already addressed to user support if you have questions. This is a link to the Google group page for for SAM, and then this is a link to the SAM website. Okay, I'm going to take a moment to pause and take a quick look at questions here. So there's a question about the color of the input fields. You'll notice that there are some of the input variables have green or blue type, and others have black type. So the ones with black type are values that you can edit, and the ones with blue type are ones that you cannot edit. So SAM calculates the values in blue. Some of these questions we're going to address later, so I won't answer now. So I think I answered this question about hourly granularity. You can look at results you can look at the results and the weather data both at as hourly data. So you can compare the weather data and the results using the tabular data browser on the results page. So here we see the incident total radiation. That's the input from the weather data, and then here's the simulation output at hourly resolution. The climate page also allows you to view, you can see the climate data. If you click View Hourly Data here, that opens dView so you can see the data in the weather file in case you're interested in exploring the weather data. So we can look at the wind speed data and so on. Here's a question about currency units. There's no facility in SAM to change units. You're kind of stuck with the units that are provided in SAM. If you're very careful, you could change values. You could, if you wanted to do your financial and cost modeling using euros or some other currency, you could change all these values to your currency. But I would recommend converting everything to dollars because it's possible that it'd be easy to miss a value somewhere. And some of the internal calculations may be based on dollars. So in general, I would recommend doing your modeling in SAM in dollars. And then as far as other units, watts and so on, you're stuck with the units there. We don't have a conversion facility in SAM. And then before I continue, I'll just repeat, there's been a few questions about the logistics. So we're going to try to post a recording of this session on the SAM website, and I will post a PowerPoint presentation that has the talking points that I'm speaking from. It's going to serve as an outline of the session.